Hey guys, this is Mr. Sal. We're looking at section 6.4, where we're going to be looking at multiplying and dividing integers. So hopefully everyone's staying safe out there. Make this video so you guys can watch it at home while you are studying, and we're doing this remote learning stuff for the virus stuff. So just stay safe, stay healthy, and here we go. Now, this first objective, find patterns when multiplying integers. Now, we go back to repeated addition, right? I mean, multiplication really is just repeated addition like this up here. But the difference is, if we look at multiplying negatives, right? Like this one, this is the same as saying 4 groups of -2 right here. So you got -2, -2, -2, and -2, which is adding these all together. Now, it is okay if you wanted to just write these as subtraction as well. So if you wanted to write it something like this, that would be perfectly fine. And there's something about this that we want to understand, right? Adding -2 is the same as just subtracting 2. Just keep in mind this -2 in the front just needs to stay as -2. And when we get into talking about terms, this is going to be crucial to know that adding a negative, like we see up here, is the same as subtraction. Now in this first table, right, we're multiplying. We're starting at the top and we're going down. 5 times 3 is 15. 5 times 2 is 10. 5 times 5 is 5. And the pattern that we're really looking for in this table is to see that we're subtracting 5 each time. Right, so if we look at the table here, right here in this one, it shows -5. And between these two, it shows -5. So if we took this pattern and we subtracted 5, we'd get 0. And then continuing this pattern of subtracting 5, you get -5. And then if you took -5, that's a subtract, and subtracted 5 right there, then you would get now -10. And again, subtracting another 5, bam, -15. Alright, so that's the pattern that we're trying to find in this one. On this side, though, we can see that instead of subtracting 5, we're adding 5 each time, right? So if this pattern were to continue from 0, adding another 5, bam, you get 5. And then 5 plus 5, bam, 10. And then add another 5 and you get 15 right there. So just from this pattern we should see, and I know we discussed it in class the other day, some of you guys started noticing the pattern even with the addition, is if you take a positive here and multiply it by negative, same with these ones, then you get negative answers like this. Now again, we'll look into this in more detail. I like to expand on this rule, but it's something you guys have probably heard of before, where we say something like a positive times a negative is a negative, or a negative times a positive is a negative. Those two are the same thing. So the most basic rules are these that we see here at the top. Can we make any rules for multiplication of integers? Yes, we can. When the signs are opposites, the product is negative. So, for example, a positive times a negative is a negative. So a negative times a positive is also a negative. Then when the signs are the same, meaning a positive times a positive or a negative times a negative, we know the product is a positive. So this creates the rules. Now this is nice for these types of problems. And before we solve them, I just want to find out if the answers are positive or negative. So for each of these answers, what I'm going to do is, I'm first going to put the sign down, and then we'll do the multiplication. Now this is good if we can separate these in our minds, not worrying about doing, like in this first example, -8 groups of 5, because sometimes that gets a little confusing. Just do this one small part at a time until it becomes natural, and eventually then you can do that all together, okay? So this first example that we see, this -6 times 8, again, the first thing I want to do is determine if the answer is positive or negative. But since there's this one negative right here, and the 8 is positive, that means the signs are opposite, so I know my answer is a negative. See, then I can do 6 times 8, which is 48. So the same thing is true for this next problem. I got a negative 2 times 7. A negative times a positive is a negative. So I write the negative first. Then I do 2 times 7, which is 14. I'm even separating the colors on this so that we can see. We're doing these one part at a time. So next, where it's 3 times negative 9, again, a positive times a negative is a negative, and 3 times 9 is 27. So in this next set, I got a negative 3 times a negative 8. Since both of these are negative, we know the answer is a positive, and 3 times 8 is 24. So the same thing is true on this next one. A negative times a negative gives us a positive answer, and 2 times 9 in this case, 18. So this next problem, negative 4 times negative 6, again the two negatives multiplied together gives us a positive, and 4 times 6 is 24. Now there's something else we should notice on these. And we can apply this new rule. It's pretty much the same as these two rules, but expanded, alright? Now again, I'm expanding on these, so these problems are going to be much bigger, alright? Now don't be overwhelmed by them, alright? Just think about what the numbers would first think if the answer is positive or negative, and then do the evaluation or the actual multiplication on this. Now this is the problem. So the first thing that we want to do is just to determine if the answer is positive or negative. Now, to determine if the answer is positive or negative, and it doesn't matter how many factors we have in this. Like this one, we've got a lot of factors. That's okay. But we're really looking at, first, how many negatives. And this is just going to be a series of 3 questions that we're going to answer that will help us to determine what the answer is. So, first off, we say, how many negatives are being multiplied? Well, let's determine that, okay? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 negatives being multiplied. Now keep in mind, I didn't say that there was 2 negatives right here. I'm just looking at how many negative factors there are. And each of these is a factor. So when I count these, I'm not saying that there's 2 here. This is only one factor, so this only counts as 1 negative. Now the second question should be a little bit easier for us. And the number that I just found was 11, right? So since 11 is odd, that takes me to the third question, which is going to help us to determine that if the answer is a positive or a negative. And sorry, it's not really a question. It's more of the conditional part of this. So in determining if the answer is positive or negative, first, we've looked at these first 2 questions, but then if that is odd, the answer is a negative, but if it is even, the answer is a positive. Now in this case, we had 11, which is odd, so we know the answer is a negative. Negative what? Now this is where people start to get confused or a little bit troubled because it's such a long problem. But remember, 1 times 1 times 1 times 1 times 1 times 1, and I'm even going to skip the 5 there, right? Times 1 times 1 times 1 times 1, all of that equals 1. Okay, now notice I didn't say negative 1 times negative 1, and that's because by determining if the answer is positive or negative, I get to ignore all the negatives. So then I'm just looking at the final product of 5 and 2, not negative 2, just 5 and 2, which is 10. So the answer to this large problem right here is negative 10. So again, the first thing we did is determine if the answer is positive or negative with these 3 questions. And then after that, we did the evaluation, but we ignored the negatives. So we're going to do the same thing on these next two problems, all right? Now notice they did the same thing over here, right? There's one negative. One is odd, so the answer is a negative. Over here, there's two negatives. 2 is even, so the answer is a positive. All right, so let's go through this one. We're going to follow our steps, all right? Again, we're going to say first if it's positive or negative. Now this one is showing how many negatives are being multiplied. 1, 2, 3 negatives, all right? So 3 negatives are being multiplied. Is that even or odd? 3 is odd, so the answer is a negative. All right, so I'm going to put a negative here. Now, again, by doing this, I get to ignore the negatives. So I'm going to take those out right here, okay? So just erase them. And then I'm looking at simple multiplication at this point. And that's how I'm going to evaluate it. So I've got 5 times 1, which is 5. And then that is 5, so 5 times 3 is 15. So the answer to this one is negative 15. And that would complete this problem. Now, this may seem like a lot of steps on that, okay? But just notice, it really didn't take that long to go through all of these steps, right? So again, same exact process on this one, right? How many negatives are being multiplied? 1, 2, 3, 4. So there's 4 negatives being multiplied. Is that even or odd? Now we get an even answer on this one, right? There's 4 negatives. 4 is even. So that makes the answer a positive. So I'm just going to show the sign up here. It's positive. And again, I get to ignore all of the negatives at this point. And then I'm looking at 1 times 2, which is 2, times 3, which is 6, times 4, which is 24. So the final answer on this one would have been positive 24. Now, of course, we could do bigger problems like we did in the example for this, but these main questions will help you determine it once you, if the answer is positive or negative, and the rest is just really simple multiplication, guys. So you can do all the multiplication. I know you can. The part in green is just sometimes the negatives throw us off, but if we go through this process of figuring out how many negatives there are, if it's even or odd, and then determining if it's positive or negative, it allows us to ignore them. And most people feel comfortable, like up here, if you had seen these 3 numbers without the positives, without the negatives, if they were all positives, you'd have been like, dude, I can do that easy. I can do that in my sleep. But throwing the negatives on there sometimes just throws us off. Now this next part is evaluating numbers in exponential form, right? But there's a huge difference between the 2 numbers that they've given us up here. And the question is, again, how many negatives are there being multiplied? Because we can expand these, right? This is just repeated multiplication. And on this one right here, where they show negative 3 to the power of 2, that gives us 2 negatives on that one, which makes the answer positive. But the problem is where we got no parentheses like we do on this one, then there's only the 1 negative making the answer negative. So if you don't see a set of parentheses, then the exponent does not apply to the negative. It just means that the answer will be a negative. So if I were to do this first example, right? Let's look at this negative 4 to the power of 2. I don't really need to think there's 2 negatives on that one because there's no parentheses. So I know the answer is a negative. And then I simply do 4 times 4, which is 16. And that would be the answer for this one. Now this next problem, it has a negative, but it's in the parentheses, which means there's 10 negatives, which makes this answer a positive, because 10 negatives, 10 is even, so the answer is a positive. And from there, you just simply do 1 times 1 times 1 times 1. You do that 10 times, and you get positive 1 on that. Now, this next example, and this is where things can get really confusing, is here I've got the negative, but remember, it's on the inside of that set of parentheses, and there's a negative. How many negatives are being multiplied on this one? There's 3 negatives, which makes my answer a negative. And from there, I just do 3 times 3 times 3, which is 27. So the answer to this one is negative 27. Now on this next example, we've got these 2 negatives right here, but then this third negative, all right? That's 3 total negatives. 3 is odd, so the answer is a negative. Now again, at this point I'm just ignoring the negatives and I'm simply doing 8 to the power of 2, which is 8 times 8, and that would be 64. Now again, on the next example, I would first look at these 3 negatives from the exponent, right? This is negative 5 times negative 5 times negative 5, which is 3 negatives, but then we have this one leading in the front right there. That's 4 negatives, which makes the answer a positive. And then we simply evaluate 5 times 5 times 5, which is 125. So that's a positive 125. Now this next question, again, the negative is not in parentheses, which means the answer is just negative because there's only one negative. And then again, you go back to 1 times 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 1. That's 8 ones. That's a negative 1 right there. So the product was just 1. But then the 1 negative makes it a negative answer. Now the rules for division are pretty much the same as they are for multiplication. It's just usually when you look at division, you're only looking at dividing with 2 values. So there's no real reason to expand this, but the same rule would apply if for some reason you had repeated division. So again, we'll just repeat this. A positive divided by a positive equals a positive. A negative divided by a negative equals a positive. And again, that's because the signs are the same, but when they're opposite, like a positive divided by a negative, or a negative divided by a positive, then you get these negative answers on this.